The topic of this video is identifying the turning points and end behavior of a polynomial function. Let's look at a problem. For f of x equals negative 7x squared times the difference x squared minus 7, part C, determine the degree and maximum number of turning points, part D, determine the end behavior. Okay, so it is possible to determine the degree in two different ways. It's also possible to determine the end behavior in two different ways. So we're going to use a different approach in this particular video. So the first thing I'm going to do here is I'm going to distribute the negative 7x squared to change my function from factored form into polynomial form. So negative 7x squared times x squared makes negative 7x to the fourth. Negative times negative is positive, and 7x squared times 7 would be 49x squared. This is another way to write our function. We have now changed it from factored form, which is a bunch of things being multiplied, to polynomial form, which is a bunch of things being added. Okay, once our function is in polynomial form, it's very easy to determine the degree and the end behavior. The degree is simply the largest exponent of x. The largest exponent of x is 4. So that means that this is degree 4. Once we know the degree, we can get the maximum number of turning points using our math elevator. Okay, the degree is 4, so we'll put the d car on the 4th floor. That means the t car must be somewhere beneath because d over t, it could be at 0 or 1 or 2 or 3, but the maximum that it could be would be at 3. Maximum number of turning points is 3. Okay, that answers part C. Part D, determine the end behavior. Well, when your function's in polynomial form, the end behavior is just the leading term, so we get y equals negative 7x to the 4th power. And that completes this problem.